In this video, we're going to talk about solving two-step equations where there is division and addition involved in the original equation. As we solve our two-step equations, our first step is always going to be to isolate the term with the variable in it, and the second term is always going to be to isolate the variable itself. We do both of those steps by using the opposite function, okay, with the same number as we try to undo what the problem is trying to show us. The goal is to have the variable, whatever it is, I use an x, equals some sort of number. So we look at our first example, x over 2 plus 3 equals 11. So this right here is my term that has the variable in it, x divided by 2. So that's the term that has it. The little blue circle is a force. Think of it as a force field that keeps everything inside of it protected. So I need to get rid of everything outside of that force field. Get rid of it on that side of the equation. So how do I get rid of a plus 3? Using my opposite function, same number, I'm going to use subtract 3. And when I do so from one side, I obviously have to do it from the other side to keep my equation balanced. So these 3's will cancel each other out. I'm left with x divided by 2 equals 11 minus 3, which gives me 8. So now in step 2, it says to isolate the variable itself. So there's my variable. There's my protective force field, protects the x. So what is happening to that x? It is being divided by 2. So how do we undo divide by 2? We multiply by 2. So I'm going to multiply by 2 on the left side and multiply by 2 on the right side. Those 2's end up canceling each other out. I'm left with the x here equals 8 times 2, which gives me 16. That becomes my final answer. Okay. How do we check and make sure our answer is correct? We plug it back in. So we look back at our original equation, x divided by 2 plus 3 equals 11. So we plug our answer, which was 16. We plug it in for the x. 16 over 2 plus 3 equals 11. 16 divided by 2 gives me 8. Plus 3 equals 11. And 8 plus 3 gives me 11 equals 11. Therefore, I know that my answer is correct because I just checked it. And you'll be able to do that with both of the other two examples that we have. So as we look at our next example, x divided by 4 plus 9 equals 25. Again, my protective force field around x over 4. So what's not in the circle? The plus 9. How do I get rid of plus 9? Subtract 9 or minus 9. Minus 9 from both sides. Those will cancel each other out. The x over 4 equals 25 minus 9, which gives me 16. There's my variable. Second step is isolate the variable by itself. The variable is in its protective force field, so what's happening to it? It's being divided by 4. How do we undo divide by 4? We multiply by 4 on both sides. Times 4, times 4. Those will cancel. X equals 16 times 4, which is going to give me 64. Okay? And our last example over here, x divided by negative 3 plus 12 equals 36. And you're saying to yourself, the negative isn't with the 3, it's with the whole thing. And yes, it is. But because we want to eliminate as many steps as we can, we're going to go ahead and take that negative from being out in front of it, and we're going to apply it right to the 3. That's going to save us a step in a little bit later in the problem. So what we're going to do, put our force field around x over negative 3 plus 12 equals 36. So what do I have to get rid of? I have to get rid of the plus 12. That's because it's not in the circle. So since it's not in the circle, we're going to subtract 12 from both sides. The 12's will cancel on the left-hand side. I get x over negative 3 equals 36 minus 12, which gives me 24. So now there's my variable all by itself. It's being divided by negative 3. So how do we get it by itself? We multiply by negative 3. Multiply negative 3. Multiply negative 3. Those cancel each other out. X equals 24. Positive times a negative is a negative. 24 times 3 is 72. Gives me my final answer. All right, again, isolate the term with the variable. Isolate the variable itself. You do both of those things by using the opposite function and the same number than what you see in your original problem. Thank you.